Let's now look at the tanh activation function, and here what we have on the left hand side are values of x that go from -10 to +10, and we are going to use that as an input to the neuron A, which is using this time the tanh activation function, which is simply the tanh value, which is shown in the output in the column A, that is right here. And on the right hand side we have the plot in which the blue line shows the shape of the tanh activation function, and the magenta colored dots are the data points that are shown in the column A. Let's now see how we can use this in TensorFlow. So here in TensorFlow, we'll first create a set of values for using the tanh activation function. We'll create values x is equal to tf dot linspace, and the values will go from -10 to +10, and we'll create a set of 100 values, and then we'll create the activations in y. So tf.keras.activations.tanh and input value of x. If we now try to plot the values of x and y, and we put a plt.grid around it, and then say plt.show, we see that the shape is similar to the softsign, where it squishes between +1 and -1, and uh, the sigmoid function. We'll look at the overlay of that as well. Let's now try to calculate the values of y again in a different way by simply using the math.tanh, and we can tanh of x, and we can plot them plt.plot in x comma y2. It should be an exact overlay plot of these, and that's what we see. What we can do next is create a overlay plot of sigmoid function and the softsign function. So let's put a sigmoid, and then let's use a softsign function, and that's what we'll put here, sigmoid. So sigmoid, and then we have the softsign, softsign, and we can use that to plot as well. So for this, we'll create the label is equal to tanh, and just copy this, paste it down below. And for this one, we have the sigmoid. Then for this one, we have the softsign. So again, copy this for sigmoid, copy this for copy this for the softsign, and we need to see the legends. So we'll type plt.legend and run this. So in the output, we see a nice comparison between how these three different similar shaped functions look like. As we would expect, the sigmoid values squish between 0 and +1 for y, and then the softsign goes from -1 to +1, but they are approaching -1 slowly as compared to the tanh. Tanh reaches the -1, close to -1, very fast as compared to the softsign function that we have. If we increase these values, and let's say if we go to 100, this will show a kind of a contrast between the tanh. So tanh, as you can see, it's a pretty sharp fall to this -1 as compared to the softsign function that we have. So that was it for this video. I hope in this video you got some intuition about what tanh function, how the tanh function looks like, how it compares with the sigmoid function, how its shape compares with the softsign function. In the next video, we'll look at yet another activation function. Until then, please like, share, and subscribe. Thank you.